Okay, so examples 2 and 3 extra practice. If you are watching this, kudos to you for sticking on for extra stuff and making sure you really understand it. That's great. So 3, 4, 5, 6, graphing the functions. I zoomed in so that we can see this graph a little bit better. Sorry I didn't do that in the one before. But what I already have done on each of these are the parent functions, just so we have them to look off of. Now I didn't make them in the table, as you'll see here, but I did make them on the graph. Okay, so it's less for us to have to write in. But we are just going to use these points, -2, -1, 0, 1, and 2. And then this is my first one. So I encourage you, let's see if we can think about what's going to happen before we actually graph it. It's a positive number, so it's still going to be facing up. It's that smiley face. And then secondly, this number, this A value, is between 0, well, I should put A, between 0 and 1. So that's, if you remember, that's when it started to get really wide. That's when it gets loose like this. So we should end up getting a graph that spreads out, known as a vertical shrink. Okay, so let's see if that's what we end up getting. I'm going to change my pen. Let's do blue. How about that? So this is going to be 1/4 times -2 squared. Okay, doing PEMDAS, that is 1/4. -2 squared is +4, and 1/4 times 4 is 1. Okay, this one's going to be 1/4 times -1 squared, which is 1/4 times +1, or 1/4. 0 is always going to be our nice one. And then the question that I always get in class is, once you get, so that's 0, you don't have to spell that out quite in detail like I did. Once you get these, do you have to go ahead and do 1 and 2, or can I just say that this is going to be 1/4 and that's going to be 1? And my only caution would be, you can jump and just say the final answer, but if you messed up here, you're going to end up messing up down here. So I just like to go through it. It's good math practice, plus it's a good double check to say, oh yeah, I got the same thing. And then similarly in this case, 2 squared is 4, so now I'm going to have 1/4 times 4, and 1/4 times 4 is 1. Oh, same answer. So it's a nice little check. All right, let's see. So again, if it helps you, write out what the ordered pairs are. -2, 1. And I got that from -2, 1. The next one's -1, 1/4. -1, 1/4. Then we have 0, 0, +1, 1/4, and +2, 1. Okay, all right. So graphing these, -2, 1 is right here. -1, go away, -1 and +1/4. That's going to be hard to see, but approximately 0, 0, 1 and 1/4, and then 2, 1. All right, and look at that. It's what we said. So this is going to be what's known as a vertical, I'll just write V, vertical shrink. And the factor is by a factor of 1/4. Good work. Okay, let's try the next one. It makes you really appreciate how fast, like when we went on Desmos, how quickly it does it for you. But again, that's not the end all be all. Graphing functions with no purpose is really pretty unpurposeful. So we're going to end up getting to the word problems, but we'll do those after we've practiced graphing. So let's move on. Here's our parent function. This one's going to be 5 times -2 squared. -2 squared is +4, so this is 5 times 4. That's going to be a big number, 20. All right, then we have 5 times -1 squared. -1 squared is 1. 5 times 1, which is 5. 5 times 0 squared is 5 times 0, which is 0. 5 times 1 squared is 5 times 1, which is 5. And 5 times 2 squared, 2 squared is 4, so it's 5 times 4, which is 20. And again, I've emphasized it before, but you have to do this first. That's where that 4 comes from. Or -2 squared, that's where, again, the +4. -1 squared, +1. Make sure you do exponents first. All right, so I'm guessing this one's going to be facing up as well, because it's a +5 5. And because this number is, my a value is greater than 1, that's when it's going to get really narrow. It's like that jump rope, that vertical stretch. All right, so I'm thinking it's going to be narrow, and let's see. So my ordered pair is -2, 20, -1, 5, 0, 0, +1, 5, and +2, 20. So -2, 20, this goes up 4, 8, 12, 16, we'll say 20 is right here. Then we have -1, 5, not too much. Then we have 0, 0, +1, 5, and 2, 20. All right, so this graph, let's just get rid of that. I'll put my 20s back in, approximately, let's say there. All right, and that's, try that again. That, one more time. That is my narrow graph. So I would say in this case, vertical stretch by a factor of 5. All right. So let's try 2 more just to get a little bit more practice. And eventually you're going to be able to look at these and not get all the points, but at least like we're doing here, practicing to see what you think it's going to look like, to get a feel for it. So you might, if you're given options, which I think in homework it's multiple choice, then you can say, oh yeah, well it's definitely not this one, because for instance, in this case it's a negative, so I know my graph should be upside down. If they give me options where it's A looks like this, B looks like this, C looks like this, I know it's none of those. So you'll be able to think through some of this. That's why we're trying to talk about these properties. All right, and then we have a 3. So my a value 3 is greater, so this is when it gets narrower. Okay, so that's what we're looking for. I'm thinking this is going to be an upside down narrow graph. So let's go to it. -3 times -2 squared. -2 squared is 4, so it's -3 times 4, which is -12. -3 times -1 squared. -3 times +1 is -3. -3 times 0 squared is -3 times 0 or 0. -3 times 1 squared is -3 times 1. -3, and lastly -3 times 2 squared. 2 squared is 4, so -3 times 4, which is -12. So I'm writing the ordered pairs out. You don't really have to do that, but it helps you to see them. And 0, 0, 1, -3, and lastly 2, -12. All right, so -2, -12 goes up to the top. And then we have -1, -3, 0, 0, 1, 3. Oh, I graphed it upside down. Sorry, let's try that again. Something didn't seem right. -2, -12, down here. Let's get that in. -2, -12, -1, -3, 0, 0, 1, -3, and 2, -12. So just like we guessed, it's going to be upside down. So that's what's called a reflection. You're looking in the mirror, it's reflected over the x-axis. And then the other thing that we can say is that it is a vertical stretch, meaning it got narrower by a factor of 3. Okay, I don't say -3 because I already took that into account when I said it's a reflection. That's the only reason I say it's just a vertical stretch by a factor of 3. All right, last one. Now I've changed this. It said -0.1. I'm just going to change it to -1/10, but you're welcome to keep it however you like. All right, so we have -1/10 times -2 squared. -1/10, -2 squared is 4, so it's -1/10. That's a negative there, times +4, so that gives me -4/10 for all you fraction lovers out there, and that gives me -2/5. Okay, next one, -1/10 times -1 squared, -1/10 times +1, so that's just -1/10. This one's going to be -1/10 times 0 squared, which ends up being 0. Then I'm running a little off. out of line here, but this is just negative 1/10 times 1, so it's negative 1/10, and negative 1/10 times 2 squared, negative 1/10 times 4, so it's negative 4/10, or again, negative 2/5. If I guess, it's going to be negative, so it's upside down. And then specifically 1/10, which is why I turned that into 1/10, because we might be a little more familiar with it that way, but maybe not. It's when we have our a value between 0 and 1, so this is going to make it wider. So in the end, it should be something like that. That's what I'm thinking. Okay? All right, I'm going to erase actually a lot of this. And it was negative 2/5 and negative 1/10, and I'm just going to fill that in. So we had negative 2/5, negative 1/10, 0, negative 1/10, negative 2/5. Okay, so negative 2, negative 2/5. Now 2/5 is 0.4. That's going to be really tiny. So it's not even a half. It's like right there. Negative 1, negative 1/10. Well, negative 1/10 is even really close, much closer to the x-axis there. So we end up getting something. Looks like this, and it matched what we said. One, it's a reflection in the x-axis, and we knew that because of the negative sign. And then the second thing that we can say is that it is a vertical. That's what my V stands for. I'll write it just in case you're stuck. A vertical shrink by a factor of 1/10, or 0.1. You could write that too. So that's what we have. And again, the reason we don't have the parent function values up, but if I would look at the y values from before, for my orange one, my orange graph, my y value for negative 2 is negative 2 squared, which is 4. This is negative 1 squared, which is 1, 0, 1, and 4. And so these are, if I compare these, my y value changes by a factor of 1/10. 1/10 of 4 is 0.4. 1/10 of 10 is 0.1, or 1/10. Zeros stay the same, and so on for those. So that's why it's called a vertical shrink, because this is what it used to be, and it turns into those. So it shrinks. That y value, that vertical element, shrinks. All right, that's it. Good work. Try the homework questions out. If you have some questions, by all means, stop in to see me. Thanks for the hard work. Bye, guys.